Proof. To prove the sine rule for all triangles, we must consider separately acute angle triangles and obtuse angle triangles. Case 1. Acute angle triangle. In the acute angle triangle shown opposite, h over b is equal to sine of a. This is because of SO, which comes from SOHCAHTOA, which tells us that sine of x is equal to the opposite divided by the hypotenuse. So the angle on the left is labelled as angle A. The perpendicular is labelled as h, so the perpendicular height of the overall triangle is labelled as h. And the pink side is labelled at b, so this would be the hypotenuse of the actual right angle triangle that's inside the larger triangle. So we know that sine of x is equal to opposite divided by hypotenuse. So sine of a is equal to the opposite, which is the height, over the hypotenuse, which is the b. So that's where h over b equals sine a comes from. Now if we solve for h, or rearrange to get the h in its own, we need to multiply across by b. So we get h is equal to b sine of a. Also, h over a is equal to sine of b. So if we take the right angle triangle on the right, this is our angle, angle b, and again, sine of x is equal to opposite over hypotenuse. The opposite in this case is h, the height, and the hypotenuse now is a, the blue side. So we have h over a equals sine of b, and rearranging to get the h in its own, multiplying across by a, we get h equals a sine of b. So since we have h equals b sine of a, and h equals a sine of b, we can let both of these expressions equal each other, because both of them are equal to h. So equating the two expressions for h, we get b sine of a is equal to a sine of b. Case 2, the obtuse angle triangle. So in the obtuse angle triangle shown over leaf, or over here, again we have h over b equals sine of a. So the angle a. So again we know sine of x is equal to opposite divided by hypotenuse. So if this is the angle, then the opposite is actually going to be the h, the perpendicular height, because remember we can only use SOHCAHTOA with a right angle triangle. So it's going to be equal to the opposite, which is h, divided by the hypotenuse, which would be b. So that's where h over b sine of a comes from, and rearranging to get h in its own, we get h equals b sine of a. Also, h over a is equal to sine of 180 minus b. So we're trying to figure out what this angle is in here, and we know that this is angle b, this obtuse angle is angle b, and this is a straight line. So this angle here must be 180 minus b, because angles on a straight line add up to 180 degrees. So we're going to call this sine of 180 minus b, and that's going to be equal to the opposite, which is h, the height, over the hypotenuse, which is a, the blue line. So that's where h over a equals sine of 180 minus b comes from. Again, rearranging to get the h in its own, we're going to multiply across by a, so we get h equals a sine of 180 minus b. And this gives us h equals a sine of b, as 180 degrees minus b is going to be the reference angle for b in the second quadrant. So equating the two expressions for h, so remember we got h equals b sine of a, and we got h equals a sine of b. So we have b sine of a equals a sine of b. So in both cases, we have b sine of a equals a sine of b. So we're going to rearrange the equation so that we have b over sine of b is equal to a over sine of a. So it's basically the opposite of cross multiply. So if we were to multiply this out, it would be b multiplied by sine of a would give us b sine of a, and a multiplied by sine of b would give us a sine of b. So we get b over sine of b equals a over sine of a. And similarly, by dropping a perpendicular to the side b, so this is the side b, so if we're to drop a perpendicular there, we can show that a over sine of a is equal to c over sine of c. Thus, sine a over a is equal to sine b over b is equal to sine c over c. And now we have proven the sine rule.